Solving systems of equations. Solve each system of equations by substitution or by elimination. If the system does not have exactly one solution, state whether it has no solution or infinitely many solutions. Well, to determine if we're going to use substitution or elimination, and keep in mind you could use either one at any time. If it's easy to get one of the variables by itself, I would use substitution. So for example, in this first equation, pretty easy to get x by itself because it already is. So this is going to be, this one here is by substitution. You're replacing one of the variables with something into the other equation. So I'm going to replace the x here with 7 because it's equal to 7. Now I have one equation in one variable. So I should be able to solve this pretty easily. We get y is 1. We already knew that x was 7, so the solution to this is the ordered pair 7, 1. X is first, y is second. Let's check out the second one. This one, it's not incredibly easy to get x or y by itself, and in addition to that, if we were to add these two equations together, we would be able to eliminate one of the variables. For example, if we add these two equations together, 5x plus 2x is 7x, a plus 4y and a minus 4y is 0, and a minus 9 and a minus 40 is a minus 49. Then to get x by itself, divide both sides by 7, and we get x is negative 7. Once we know that's negative 7, we can then take one of these equations that's from the beginning, doesn't matter which one. I will use this one for no particular reason. And we can substitute in for the x's a negative 7 so that we have an equation in one variable again. 5 times negative 7 is negative 35. If we add 35 to both sides, we get 4y is 26. If I added correctly, and then if we divide both sides by 4, we're going to get y is 26 over 4, which reduces to 13 over 2. So the ordered pair for this one, negative 7 and 13 over 2, or you could write as 6.5. It's okay to get decimals and fractions. Number 3, we could use elimination or substitution for this. I'd probably use substitution since y is already by itself. I would take this equation and I would rewrite it, and every place I saw a y, I'd replace it with 3x minus 2. Replaced y with 3x minus 2. Notice there was a subtraction in front of the y, so I have to put it in parentheses when I substitute. Should always use parentheses when you're substituting. Wow, this is weird. If we continue to simplify this, we're going to get 3x minus 3x plus 2, distribute the negative. The 3x's cancel, we get 2 is equal to 7. If at any point your variable is eliminated, like it is here, you have to assess, is your statement true or false? Does 2 equal 7? It does not equal 7. If your statement is false, this problem has no solution. What would that mean graphically? It means if we were to graph these two equations, they would be parallel to each other. Parallel lines have no ordered pairs in common because they never intersect. Long story short, if you get a statement that's false, it's no solution. Let's check out number 4. Let's see, getting y by itself would not be easy. Elimination doesn't seem like it's going to happen organically. But here's what we can do. We can take this equation here and we can multiply every term by 2. What would that do for us? If we leave the first equation the same and multiply each of these terms by 2, we're going to get 4x plus 4y equals 0. So what does that do for us? If we now add these two equations together, this is elimination. Should have mentioned on this previous one, this one was substitution. You can use any method on any problem. Just try to use the one that we find is the easiest. If we add these first two terms together, we're going to get negative x. The y's cancel. So then we end up with x is negative 5. To figure out what y is, we can take any of these four versions of these equations. I'm going to choose this equation. I'm going to replace the x with negative 5 to get y by itself. It's going to be negative 10 plus 2y is 0. 2y is 10. That means y is 5. The ordered pair for this is the ordered pair 5, negative 5. Number 5, you may look at this and think, dear Lord, how am I going to be able to do this one? There's fractions all over the place. Well, let's get rid of our fractions. I'm going to rewrite this equation. I want to get rid of the divided by 7 and divided by 3. So I'm going to multiply each term by 7 and 3. That's the same as 21. What does that do for us? On this first term, the 7's cancel, so we're left with 3 times 4 times x, which is 12x. On the second term, the 3's cancel, so we're left with plus 3 times negative 2 times y, which should be a subtract 14y. And over here on the right, 3 times 2 is 6, 6 times 7 is 42. That doesn't help us with elimination, but it helps us with the fact that this equation doesn't need to have fractions in it. If I then take this fella, let me just kind of separate what's happening here. If I take this fella and divide each term by 2 to get y by itself, I would get this. Then I would do this problem by substitution. So I'm going to replace the y in this equation with negative 2x plus 20. When you substitute, use parentheses every time. We could distribute the minus 14. I made a mistake over here. I apologize. This is not correct. This is also not correct. If I divide each term by 2, it's going to be y equals negative x plus 10. My apologies. So this would be a negative x plus 10 over here. If I distribute the minus 14, I'm going to get plus 14x, and a minus 140 equals 42. Combine like terms, it's going to give me 26x. If I add 140 to both sides, I'm going to get 26x equals 182. If I divide both sides by 26, I get x is 7. We need to know what y is. So if I plug this into one of my equations, I'll plug it into this one since y is already by itself. We're going to get the ordered pair 7, 3. Now at certain points, you might find that what you have when you're done is a mess. I did this first. I did this second. I did this third. I did this fourth. And I got this answer fifth. One more. Oh, decimals. That's terrifying. Or is it? We could take this bottom equation and we could multiply it by 100. It's the multiplication property of equality. Why 100? Because the number of decimal places that I have is 2. If I multiply these by 100, I'll write this down here. I'm going to get 75x plus 15y equals 255. Now, if I want to simplify this more, I could divide each of these terms by 15. If I divide them each by 15, it's going to give me much smaller numbers. So it's not something you have to do, but it's something I'm going to choose to do since these are all multiples of 15. That's going to give me 5x plus y equals 17, I believe. So once again, the great thing about algebra if you know algebra rules, you can do lots of different things, and you can do things in lots of different ways. I'm going to take this top equation. I'm going to get x by itself. It's going to be x equals negative 2y minus 2. Then I'm going to substitute this in for this x here. So we did this first, I did this second, doing this third. That's going to be 5 times negative 2y minus 2 plus y equals 17. If I distribute, I'm going to get negative 10y minus 10 plus y is 17. Negative 10y plus y is negative 9. If I add 10 to both sides, I get negative 9y is 27, so y is negative 3. Figure out what x is. I'm going to come up here and replace this y with negative 3, and I'm going to get 4. I got 4, negative 3. This one I use substitution. You can do these problems in lots of ways. You're going to get the same answer every time as long as you do it correctly. You can use elimination or substitution for any problem. So that concludes the notes, and thank you for paying attention.